Hello, our team, Nurberdiyeva Bigaisha, Mashakova Danel, and Khamidullina Aliya, made project containing of 6 parts. First part of our project is calculating the probability of each symbol.
Here is my input sequence of 200 characters. We calculated probability with using ASCII code. That is why we use two arrays. First array contains count of characters, second number in ASCII. I go through the loop and it increments the count of each symbol in ASCII. Then in second loop, we calculated the probability with dividing the number of repeats to the length, and we write to the file output.txt. It is empty now. After running the code, we can see the result.
Here it is part 2. This part about Huffman encoding. Input gets from part 1 in format as character and probability. In details, we will explain about main functions of code. First one is handle new string. Here we handling with input signs and probabilities. We need a class node to initialize each branches left and right, and leaves as character and probability as value.
Node constructor for initializing branches as root to leaf path.
Encode text, in which tree map variable codes consist of a generated code as a dictionary, key and value.
Boolean function utility is same character set, checks frequency of characters.
Build tree constructs a tree that is used for data compression, and print codes function as a key value. Format key is a sign and value is a code. Then we're using functions from file to read the input text and to file to get our output. In part 3, we need to decode the result from previous part. Just as before, we're using Huffman tree and H node construction. Here it starts to iterate through the encoded string and assign nodes. Then, while none of them is empty, it's important to define if character is 1, move node to right, and if opposite, to left. When we append the last node, decoded result is saved in output string.
Then we go to generate codes function, which run from the root of the encoding tree and follow a left branch for a 0, a right branch for a 1. Again, in this code, attention goes to class node, where at the beginning we need to assign values to subtrees, so that in the constructor node we initialize right and left values branches. And again, same reading from input and saving in output.txt.
Starting with the Hamming code in part 4, first for input we get an encoded sequence from part 2.
In which main goal is to construct 4-bit blocks. If there needed an extra bit, expand initial length for array and insert zeros. Convert I1, I2, I3, I4 data bits to Boolean variables for XOR check to parity bits. Vice versa, convert parity bits to binary variables.
Then get the Hamming 7-4 code, in which 7 is the number of overall bit in block and 4 is the data bit. In this part, we write the code to the file named as output.txt for part 4. In this part, we are working with marking arrows, as we did in the laboratory work 7. Firstly, we have read the output file of fourth part, and after reading this file, we are starting adding the arrows.
Данель, это четвертое. We have a lot of blocks where each of them containing of 7 bits, and error may be only in this length. Error must be in a random place of each block where we add it. If block speed equals to 1, we change it to 0. If equals to the 0, we change bit to the 1.
In last part 6, we do Hamming decoding. After manipulations with binary and Boolean conversion for XOR, we go to check error syndrome function, where at any case return index of a bit which has error.
Then, as a main part of decoding, we convert 4 data bits and 3 parity bits from binary to Boolean. Then calculate error syndrome using cases for S1, S2, S3, and determine index of error.
Here, so in delete parity function, we can correct error by changing 1 to 0 or 0 to 1, as always saving results in output txt.
And also in part 6, as an additional note, we need to get the output from part 6 and put it as an input for part 3. So I'm copying it and I'm clearing the output for part 3. I'm replacing it in part 3. And I'm running it again. And as we can see, the result is the same as the initial 200 characters text. That's it. Thank you for your attention.